All right, section 5.5, the last section in college algebra. All right, systems of inequalities. All right, if you remember inequalities with linear inequalities, which I believe was chapter 1 or chapter 2, all right, we graphed those. Okay, we had a number line and we said, okay, maybe it's less than 5. Okay, so if x was less than 5, we would shade to the left of 5. And then since it had a less than, we put an open parentheses on it. Okay, systems of inequalities. Okay, we're going to graph linear inequalities. Okay, or graph inequalities of on a two-dimensional plane, and then we're going to shade accordingly. Okay, so here's how we graph a linear inequality. First thing we do is replace the inequality symbol with equal sign and graph that line. Okay, we draw a solid line if it has a less than or equal to or greater than equal to. So if it's got a line underneath it, it's solid. We're going to use a dashed line or a dotted line if it's strictly less than or strictly greater than. So no line, dotted line. It's kind of like parentheses and brackets. All right, then we can, step 2 says, choose a test point from one of the half planes. Okay, when you draw that line, it'll separate the graph into two half planes. Okay, you're going to choose one of those points and plug it into the inequality. If it's true, you're going to shade that side. If it's false, you're going to shade the other side. All right, so let's look at this one right here. All right, step 1 is we're going to replace the inequality with an equal sign. Well, actually, we're going to go ahead and solve this out, and then we'll replace it. All right, so I want to get the y by itself. So I'm going to take my 2x minus 3y, which is greater than or equal to 6. I'm going to subtract the 2x over. This gives me negative 3y is greater than or equal to negative 2x plus 6. I can't put the x and the 6 together because one has the x, one doesn't. All right, then I'm going to divide by the negative 3. You're going to divide everything by the negative 3. All right, so you're going to get y. You're going to get 2/3 because negative divided by negative is a positive. And then you're going to get 6 divided by negative 3 is a negative 2. And then remember, since we divided by a negative, we have to flip that symbol over. This becomes less than or equal to 2/3 x minus 2. All right, if we remember from graphing lines, we now know our slope is 2/3, and our y-intercept is negative 2. So we can go over here and put a point on negative 2 on the y-axis, and we go up 2 over 3. Up 2 over 3. Okay? Up 2 over 3. Now we're going to draw our line. Since it has the line underneath it, the or equal to, our line is going to be a solid line. Okay, so we're going to take a solid line and we're going to graph it through those points. Okay? All right, notice how the coordinate grid is now broken into the stuff up here on top and the stuff here on bottom. All right, it says pick a point in one of those half planes. All right, so I would probably pick, let's say, you can pick any point you want. Maybe let's pick this point right here, 1, 1. This is our test point. All right, now we plug the test point into either the original inequality or the inequality we solved and see, is that going to be true or is it going to be false? If I plug it into the one that I solved out for y, we get a y value of 1. So again, I'm going to do my test value, which is 1, 1, is 1 less than or equal to 2/3 of 1 minus 2. All right, and if you stick that 2/3 times 1 minus 2 in a calculator, all right, that's going to give me a negative 4/3, or a negative 1.333333. All right, now the fact that it's negative, you can say, is 1 less than a negative 4/3? That's false. Since that's false, we know that 1 is not part of our solution, and neither are any of the other points on this side of the plane. And my answer is going to be shading the left side or bottom side of the plane. So any of the ordered pairs on the line or over here in the shaded area are going to be solutions to this linear inequality. Now, if we're talking about lines, okay, we actually can do a little shortcut here. All right, once we have it all the way solved out, like we do over here, written in line form, if you look at the inequality symbol, if it's less than, you're going to shade below it, and if it's greater than, you're going to shade above it. Okay, test value always works, in case you're stuck and can't figure out. But if we have lines, less than means shade below, greater than means shade right. Okay, the only time that doesn't, or excuse me, less than below, greater than above. Less than below, greater than above. The only time that doesn't work is if you have a vertical line, which we're probably going to see here in a second. All right, let's look at this one. All right, it's already solved out for us in y. So we know our slope is a negative 2/3. And since there's not a plus something, that means our y-intercept is 0. All right, so we're going to put a dot on 0, the origin. And then we're going to go down to over 3. Down to over 3. Down to over 3. All right, now when we graph the line on this one, notice that the inequality symbol is strictly greater than. So since it's greater than, we're going to have a dotted line or a dashed line. So we're going to draw our line, but we're going to dash it. That's going to tell us that, hey, anything on that line does not work. All right, now we need to shade. When we shade, we can say, hey, what's my symbol greater than? And so I'm going to shade above the dotted line. Shade above the line because it's greater than. All right, we can always do a test value. All right. Here we go. Shading the end. All right, again, we could have done a test value. And so I did that same test value of 1, 1. If I plug that into my inequality, is 1 greater than negative 2/3 times 1. So 1 is greater than negative 2/3. Since that's true, we shaded the half plane that had the 1, 1 in it. Okay? Now, for a vertical line or a horizontal line, okay, let's see how that works. So y is less than or equal to negative 2/3. All right, remember y, that's going to be a horizontal line. So you go find a y value of the negative 3, and you draw that horizontal line. Since it's or equal to, that's going to be a solid line. So a solid line, oh, that's dashed. Got to change my line. Solid line here at negative 3. All right, and then since it's less than, we're going to shade below the graph. So all of the graph, any ordered pair below that line is going to work. Okay, that is A. All right, for B, X and a number, that is going to be a vertical line. All right, so we put a point on the x-axis at 2, because it's x. Since it does not have a or equal to, it's going to be a dotted line. So a dashed line there. All right, and this one, what do you got to think about it? This one does not have an above or a below. Okay, but it does have a left and a right. And if it's a vertical line, greater than means to the right, less than means to the left. Because what numbers are bigger than 2, x values, the ones to the right. So since it's greater than, I'm going to shade over here to the right. All right, so that's how you do the vertical and horizontal. Now, we actually shaded these and graphed these on the same graph. And so that brings us to systems of inequalities. Systems of inequalities are, the answers are, what ordered pairs make both of those things true? All right, so where are the answers that are both less than -3 in the y and greater than 2 in the x? And graphically, that's going to be where they're both shaded. So if this were a system of inequalities, we would just shade down here in the bottom. When we shade down at the bottom, those are all the answers that are both less than -3 in the y and greater than 2 in the x. All right, so let's do one of those. All right, let's graph this system of linear inequalities. So I'm going to do each inequality. X minus y is less than 1. I solve that for y. I'd subtract the x. Get negative y is less than -x plus 1. I'd divide out the negative in front of the y by dividing by -1. So the first inequality becomes y is greater than, I had to flip because of the negative, becomes a positive x and a -1. So that has a y-intercept of -1 and a slope of +1. So up 1 over 1, up 1 over 1. It's a dashed line because there's no or equal to. So I draw my dashed line right through there. All right, and then when I shade, I would have shaded above. All right, and so for systems, I'm actually going to do something a little bit differently. I'm just going to kind of draw some arrows saying, hey, I would have shaded this direction if that's the only, if that was all by itself. I would have shaded greater than or above it. All right, we'll come back and shade here in a second. All right, now I'm going to come back and I'm going to do the second inequality. 2x plus 3y is greater than or equal to 12. I solve that for y. I'd subtract the 2x, so I get 3y is greater than or equal to -2x plus 12. Divide the 3 out. That's going to give me y greater than or equal to, I did not have to flip because I did not divide by a negative. It gives me -2/3 x plus 4. So I go find 4 for my y-intercept, and then down 2 over 3, down 2 over 3, down 2 over 3. It's going to be a solid line because I have the or equal to. And I'm going to graph my line. There you go. All right, where would I have shaded? It's greater than, so that means I'm going to shade above it, which would be this direction. All right, and so notice that those two lines break my plane into 4 sections. Okay, over here to the left, down here in the bottom, to the right, and then on top. And so your answer is going to be the region where I would have shaded both times. So I would have shaded all the way over here to the above the blue line, and then all the way over here above the pink line. So where did I shade both times? I was shaded both times in this section up at the top. Okay, so I would have shaded right up here. Okay, notice that I have arrows in for both lines in that section. All right, and for these, the graph is the answer. Okay. All right, and finally, let's look at example 7 here. All right, the first inequality is not a linear inequality. The first inequality is a quadratic. Okay, I've got y is greater than or equal to x squared minus 4. All right, so we got to remember what that graph looks like. X squared is quadratic. Okay, so that means it's going to look like a parabola. And then the minus 4 means it's going to be shifted from the origin down 4. You got to remember stuff from earlier in the class. So negative 4, and then I've got a parabola that opens up. Because it's over equal to, it's going to be solid. So I'm going to have a parabola that opens up. There we go. All right, now shading here. Okay, greater than means above, less than means down. So the shading on this one would be, since it's greater than, it would be shaded above. So it would be up here. This would have been shaded if I was just shading that one. All right, then I come through and do my second one. X minus y is greater than or equal to 2. Solve it for y, so I subtract the x. I get negative y is greater than or equal to negative x plus 2. All right, divide by the negative 1. That gives me y is less than or equal to, I had to divide by the negative, it becomes a positive x and then a minus 2. That's a line which has a y-intercept of 2, then up 1 over 1, up 1 over 1, up 1 over 1. Since it's over equal to, I am going to have a solid line. So if I can draw that out, there we go. And since it's less than, I would have shaded beneath the graph, beneath the line. All right, and then where would I have shaded both above the blue and below the orange? That's going to be my answer. And so my answer is this little area right here. This little section right here is the answer to that system of inequalities. Okay, that graph. All right, good luck. Try these out on my math lab. Send me an email if you got a question.